This is a presentation of my dissertation analysing emotions and driving styles when driving in varied weather conditions. What problem did I attempt to solve? Firstly, with the ever-increasing popularity of Internet of Things and connected cars, there are now so many areas surrounding driving that is yet to be explored. This project will look into the influence driving in adverse weather conditions has on motorists' emotions, and if a car can read emotions of a driver and adapt the driving experience to manage these heightened emotions. What have I done to solve the specified problem? An experiment has been created that records emotions in 3 different weather conditions. A data model will be trained to confirm the accuracy of the emotion detection system. Data mined will be used to discover trends in driving behaviour and the variety of emotions displayed. This valuable information will aim to have an influential impact on car manufacturers and programming their sensors within the car to aid drivers in highly stressful situations. Following this, there is a video demonstrating my artifact.
So this was the setup of the experiment. It involved participants using a mouse and keyboard to steer the vehicle. The display was from the laptop screen where the webcam was recording the participants during each drive. Speakers were positioned either side of the laptop, which allowed for realistic sounding noises. The other screen was used for myself, where I was able to see both the recording of the webcam and the simulator if the participants got into any trouble. However, this setup was only available for participants who live in the same house as me. Participants who were joining remotely were required to download OBS Studio and Steam, which streamed the gameplay. There are 3 different routes for participants to drive. All routes are of a similar distance, which include motorways, back roads, and city roads consisting of traffic lights, junctions, and roundabouts. Routes are programmed into the map as shown on the video and are displayed in the navigation system visible to participants in the bottom left corner whilst driving. The next task before the experiment begins is to start the Apple Watch to measure the heart rate of the participants. This has to be started before each drive and ended when the participants finish the route. 3 average beats per minute recordings will be produced. The scatter plot displaying the heart rate recordings are displayed to view on the Apple Watch Activity app as shown. This can help identify if participants were stressed at any time during the drive, as heart rates will fluctuate throughout. Displayed are snippets of 3 weather conditions during each drive. Drive 1, done in the daytime, but with heavy rainfall. Drive 2, also heavy rainfall, but during the night. And Drive 3, in a day in clear sunny conditions. OBS Studio allows for the webcam footage and driving footage to be linked together. This allows for participants' expressions to be linked with the road situation. You're able to identify where drivers are looking whilst they are driving. From the webcam footage recorded individually, the MP4 files can be inserted into the emotion detection system. This system will then determine the strength and type of emotion based on the structure of the facial action points. This data is portrayed in a table as well as a line graph and bar graph as shown. At the end of the procedure, a CSV file is produced that extracts the strength of the emotion and the time that the emotion was displayed. A new attribute was added which determined the main emotion being displayed during that frame. This was useful when linking with open-face output. Then a new sheet was added to calculate the percentage of the emotion over the whole drive. This information was then inputted into a database within the emotion overall table. OpenFace is the next facial recognition system used to determine expressions of participants. Similar to the previous, the MP4 webcam footage is easily inputted and the analysis will begin. OpenFace measures the movement of the action points on the face along with the gaze and eye movements. OpenFace produces a large CSV file displaying the position of each and every facial point within each frame. This large set of data is extracted for each and every participant for each drive. Now linking back to the emotion detection system output and now the OpenFace output, you can see that the amount of frames captured are the same. This is useful as now we can link the emotion to the facial structure determined in each frame. As shown, this is the combined CSV file from OpenFace and the emotion detection system. As you can see, it has the user ID and the route that they were traveling on. And then in the last column is the emotion of the participants at the time, at that frame. So as you can see, there's no emotion, neutral, happy. So this shows the variation of emotions that have been picked up from the emotion detection system and now linked with OpenFace data. A trained dataset was created in Weka using data collected across experiments, which provided training principles for all 8 emotions. The CRISP-DM methodology was followed to prepare the data to create the accurate models. Classifiers were then run on this training set, and a highly accurate model could be used to validate the algorithm used in the emotion detection system. Moving on to the database, we can see the different tables used to store the questionnaire data. The user table holds data about the participants who partook in the experiment. The driving table involves data according to the driving habits of participants. Answers for each individual question and overall scores are recorded in each of the alexithymia, PANAS, personality, and present move table as shown. Within each drive, participants were marked on the amount of road traffic offences they produced. These involve crashes, speeding offences, traffic offences such as going through a red light, wrong turns, lane positioning, risky manoeuvres, and wrong or no indication. Participants' heart rate and average speed of travel are also calculated and found in the driving analysis table.
The emotion overall table stores the percentages created from the real-time emotion detection system of emotions displayed by each participant for every drive. Each route can be filtered to determine whether adverse weather conditions produce higher negative emotions. Current limitations for this project involve realistic driving simulator, sample size, sensors, and accuracy of the emotion detection system. A realistic driving simulator was intended to be used, which involved a steering wheel, pedals, and a seat. However, due to the current situation, a keyboard and mouse was used instead. As the simulator had to be streamed, a change of simulator was required, which limited the functionality that was intended. Due to participants taking part from home, where their computer required the necessary computing power and stable interconnection, this caused sample size to be limited. It was proposed that there would be a range of different sensors used to determine emotions, including EDA, ECG monitors, along with a seating map which tracked the seating position. However, this could not be used as this equipment was at the university campus. Lastly, due to the limited time available to train an accurate facial expression tool, one that I created and trained partially was not accurate enough to be used to determine emotions during the experiment. As shown in the video where it struggled to identify emotions displayed, this meant other open source systems presented in the research had to be used. Thank you for watching.